Hello, my topic today is ice. My name is Mike McMain, and as a person, I rather enjoy ice. I really like ice in Scotch, and I like to ski. That's kind of a form of ice, and having icy roads is really fun. But for a aviator, ice is not a good thing. And we have basically two kinds of ice in aviation. We have induction ice, and that's basically in our carburetors. It's caused by the venturi part of our carburetor. And I'm not going to actually go into that aspect of ice today. What I am going to talk about is structural icing, and it is a very, very important aspect of our flying, and we really have to be conscious of it. It has a great effect on our flight. We have the possibility of loss of lift. We have increase in our weight, and we have control problems. And these are really significant in an airplane. And the thing that really determines the type of ice that we're going to accumulate is temperature and the size of the droplets. And this is a real issue here. And the water itself can be frozen, it can be cooled, and it can actually be super cooled. The closer we get to centigrade or 0 centigrade, we're going to have clear ice. And clear ice has a large droplet size, and it is very close to zero. And what happens is these large water droplets hit the structure of the aircraft, and it doesn't matter where on the aircraft it hits. But I'm just going to use the example of airfoil today. But as the larger, warmer drop strikes the front of the edge or the leading edge of the wing, because it is in the relative wind as it's going forward, it strikes the structure, and because of the large droplet, part of it will freeze at that point, and then as the droplet moves across the surface, it's going to freeze as it moves. And so you're going to get this nice, clear ice that's going to build up because it's slowly, slowly freezing over the top of your structure. We're going to find these type of droplets in cumulative clouds, basically because they're going up and down in the clouds. You've got a lot of turmoil or rising and lowering of moisture in this type of cloud. You're going to also pick it up into freezing rain, and you're also going to pick it up when moisture is warm above you and falls into a cold environment that you're in. And the biggest problem with this type of icing is weight. Weight is a big issue when we're talking about aircraft, as you know. We can build up 2 to 3 inches in less than 5 minutes. So this means that you get a tremendous buildup in a very, very short period of time in this type of icing. As the temperature gets colder and colder and colder, we get into a condition that's called supercooling. And what happens in supercooling is actually the temperature of this moisture is below 0 centigrade or below freezing, but because of the activity of the activity of the water droplets, it is not become hard yet. It's still in a liquid state. This super coolness is a very small drop, and this is what creates our rim ice. And our rim ice is significantly different than our warmer air or our clear ice. And the reason it's different is because it is so much colder and so much smaller. It strikes the leading edge of our wing or airfoil, and that strike immediately freezes. So it's not going to give us this smooth effect that we're going to find in clear ice. And rim ice is going to be opaque in color because it's going to trap a lot of air because it's not running over the edge of our structure and freezing, it's freezing immediately. So any air that is beneath the ice as it sticks to the structure is going to be trapped there. So it's going to look a little different. This is going to come from clouds that are stratus clouds that are very high and don't have a lot of moisture in them, but they do have visible moisture. And the biggest problem with rim ice is the shade. You traditionally will build up on the leading edges of things, and props and wings and airfoils and things of that nature, and it's going to affect the airflow as it travels over our wings or our airfoil. And that's going to be our biggest issue with this rim ice, is the changing of the structural shape. How do we prevent this? What do we do, or when do we worry about this? The times we need to worry about this is when we have visible moisture, when you can actually see the moisture, and when the temperature gets down less than 0 Celsius or freezing. The book only talks about these two types of freezing moisture. I'm going to actually talk about one more, and I'm going to talk about frost. And the reason that frost is so important is it sticks to the surfaces of the aircraft. It's going to give us a sandpaper type of effect on the leading edge. And so we have a barrier layer of air that is next to our structure, and this is going to destroy that barrier layer, and it's going to affect our wing a lot. We're going to get 30% less lift out of a airfoil that has frost on it, and we're going to get a drag up to 40% more than a clean wing would be. So as far as ice goes, for a pilot, we want to keep our frost on the glass, and we want to keep the ice in our drinks. So thank you very much for your time today. And this was a short presentation, but I really appreciate it, and I think it's really an important one, and it's a big safety issue. And you can really get in trouble fast with this one. So take care, fly safe.